Hello everyone, thank you for joining us today for our OrCAD PCB Standard Tips, Tricks, and What's New webinar. My name is Brianna and I will be moderating this event. And to get started, let's address a few logistics. Everyone's mic is muted throughout our time together. If you have any questions, please ask them within the questions pane. We will have a representative answering questions as well as a Q&A at the end. Orlin Bates will be our presenter today. Orlin is a senior field applications engineer and has been in the field of PCB design since 1973 and has been with EMA since 2002. Orlin attended vocational tech school, earning a degree in drafting and design technologies. With years of printed circuit, printed wire design, DFM knowledge, and high volume manufacturing, Orlin is a highly skilled professional in the field of engineering and physical design. So with that being said, over to you, Orlin.
Thank you, Brianna. Welcome, everyone, and I'm hoping you're having a good day. Today, I hope to present new information to you or strengthen what information you already have. At that point, we'll go ahead and start. I'm in 17.4 release. We now have Workspace Flow. So as you can see over here on the side, I'll go ahead and open up Setup. This workflow is set up so that you will process down through all the way to the manufacturing deliverables. And each step of the way, this is a quick way to go ahead and get the command too. So if you wanted to, like, let's say we're done with this design, I hit artwork, it pops up everything I need to generate the artworks. So look at that as a fast way to jump to where you need to do your work. When you come back the next day, you might be in placement, you might be in constraints, but this allows you to step through. As long as you follow all these steps and complete those tasks, you've got a board that is ready to go to manufacturing. With that said, the Constraint Manager is the brains of the operation, as I say. In the Constraint Manager, if I set all my rules up, the software is going to check me to make sure that I do the type of design I should be doing in there. Now, Standard does have some limitations, but not many in there. I'm famous for saying I can design any board out there with Standard, but I can hand tape boards too, but that don't mean I want to. There's things that the Pro does that is a lot easier, a lot less work, and your time is money. So if it takes you longer to do a design in Standard where Pro could help you out, the cost can outweigh itself. With that, I'll also mention that we have what's called an EDA card. I've nicknamed it the rental program. You can have Standard and purchase an EDA card, and when you need Pro, activate it. And you're activating it on your own. You're not waiting for a license to be cut for you. So that EDA card is very beneficial for people who have Standard, but every once in a while you get a job in that you need Pro, and Pro can help you do the design a lot faster. And that EDA card is a real benefit there. Other thing I want to point out in our system is the fact that there is no size limit to the design. There is literally no size limit. And I tried to break the tool to make a design that was large enough that the system would fail. I live on a farm and I have an orchard. So I made a 5-acre board and zoned out, put room properties in for all the different orchards, the apples, peaches, just to break the system. And I could not break the system. I wanted to be able to send a bug report back to have it fixed, but I was not able to break the system. So I assure you there is no limit to the size of the board that you need to build. There is a limit on the number of layers. At present, you can only have 256 layers in your board. No one has reached that limit, so we haven't been requested to increase that. I don't think anyone will be running into any problem with that. I don't think manufacturing could make a board with 256 layers at the present time. There is no limit in Standard for the number of parts or pins on a design. A lot of systems out there limit you to the number of parts and number of pins that you can have. Our system is not limiting that to you. The other thing I want to point out is let's go to our stack up. What has changed in our stack up is the fact that you can export out a cross section or an IPC 2581 or HTML file. You can also import in that IPC 2581 or the cross section tech file. So if your board house has already done a stack up for you, this is the way they're going to fabricate your board. I would not reinvent the wheel. I would take that information and just load it in, and all the information will be here for you. The thickness, copper thickness, dielectric material, that's all very important information. Our software uses that. Even though you might have standard, you could use it for other things in here, for signal integrity and other sending it out. Let's say you're outsourcing or you're getting that pro through the EDA card, and then you're wanting it to check the ohms. So you want 100 ohms on your clocks for your memory, and you want 80 ohms for USB. This information is already in the database, even though you got standard. You can move forward with Pro if you needed, and that information would already be there for you. If you've done your stack up yourself, I recommend sending it out. So export it out, send it to a board house, make sure they can build what you're asking them to build. Make sure there's no long lead times on the material. That's really important at the end of a job. You get it done, but then the lead time on some of the material could be 6 months, and that would kill some projects. So it's important to know that the stack up is correct, and this stack up can be imported, exported out. With that, let's go ahead and just cancel out of here. And then I want to go ahead and take you to setup. So under setup, under the more, they've moved it. So under the more category, there's materials. So we'll go ahead and click on that. Here's where all your materials are. Materials are changing constantly, adding new materials constantly. So if you want to, you can come in here and add new materials on here. And with that, you can create a new one or copy an existing one and make modifications to it. But we're not limiting you. You have the freedom to come in here and add new materials all the time that you need, and make sure that you have that information from the board house for the thicknesses and the dielectric material and the dielectric constants to that. You need that information to be accurate because the software will use it elsewhere. With that, let's go ahead and cancel out. So let's talk about 3D. 3D has changed quite a bit in the 17.4 version, also in the 17.2, but in 17.4 they've made some enhancements to that. We'll go ahead. I've launched this ahead of time, but there's the button to launch for your 3D. So let's go ahead and look at this. This is the board that we're looking at right now. I'm going to go ahead and flip it over. What you're seeing here is air holes, air slots being cut in here. And this pin was high speed, and it's a high voltage pin. And to pass UL and use FR4 material, we had to cut air slots in here so the voltage didn't creep across here past the HiPot test in the UL testing that we did. So that was one of the problems. So what I want to do is come back here now and orientate that right. Notice that this angle is at an odd angle. I'll talk about that a little later. But right now I want to go in and run a collision check on here. Everything looks good, right? I'm looking at it and it looks fine. And now all of a sudden I see all these problems. So I'm looking at them and they're my relays on here. And I'm not sure what's going on. And I'm seeing components and it's not highlighting the component at this level. So I want to flip it over and look. And sure enough, now I can see they're starting to light up here. Let's look at U6. U6 stands out. So we're going to go ahead and zoom in to see what's going on. And as you can see, the pins on my component is not lining up with my holes. So evidently, the step model I have for this relay is pinned out differently than what I've laid the board out for. I mean, that type of check is very important. One or the other is wrong. My pin out's either wrong or I've got the wrong step model. But this type of check notifies me that, hey, I've got a problem. So that's one of the checks that I like in here. So let's go back to 2D board. And one of the points I wanted to make is the fact that this symbol here, J1, you saw it at an odd angle. I bring that up and show you that it's placed at a 37-degree angle. And the reason I want to point that out is we have our set for 45, 90, 180, and then 0 as the 4 defaults. That does not mean those are the only angles in which you can put parts on. You just type in the angle you want. In this case here, I type in 37 degrees and place that connector at a 37-degree angle. Just because I've heard people say, well, I heard you can't put parts on odd angles. It has to be 45 or 90. And that's not true. So with that, let's talk about those symbols that you saw there. I want to get into mapping them. So we come over here to setup, and you want to come down here to step mapping. And I want to go ahead and grab my connector there, that odd angle connector. And here's my step model for it, and here's my physical part on there. And I want to compare the two. I want to make sure that they're lined up. These errors down here are the increments that you would line up. And with that, then I'm running it at 1 mil. You can change that increments, but when you get down to fine tuning, 1 mil is really where you want. Now I want to overlay the two and look at them, and they look good that way, but I also want to look at them from the front. And it's important to know that I'm seated on my board. So I got my board turned on, I've got them overlapped, and I can see that my connector is seating down on the board. That's important to make sure that happens. I would also stress that you want to do this in the library. Do it one time in your library. Everyone who pulls this part into the board will have a step model automatically. That work's done one time, everyone benefits from it. If you do it at the board level, it stays only at the board level and no one else can benefit from the work that you've done. Once everything is good, you can go in there and do a save. Save's grayed out because I haven't really modified anything. So once I modify something, the save button would not be grayed out on there. Now what I want to do is pop up that other board. And I did this ahead of time just to save time. Here's our 3D model of that board. So let's go ahead and look at this. And what you can go through and visually look at it and see that everything really does look kind of good. And now I want to rotate this. Now I want to go ahead and do my collision checks here. Shouldn't be any issues as far as I could see with the board. It looks good on there. And the collision check's about to finish on here, and I do have one problem. So here I have U2 right here saying I have a problem with C39. C39 did not highlight. I rotated on the back side, and sure enough, there's a problem there. Let's go ahead and zoom into that. We'll zoom in a little closer. And what you're actually seeing is the fact that this part is not seated down the way I would expect it to be seated down. Just as I told you that you need to go ahead and make sure that it's seated on the board, this is what has not happened here. So it's literally cut through the board. Part of it's showing on the top and the bottom part of it. So that Z-axis on this part was laid out wrong, but it was able to catch it because it's saying, okay, if that's really your part and your part's halfway through the board, you're crashing with C39 on the other side of it. So that's some of the checks that it will do. I need to go back and basically line this part up. Obviously did this for the benefit of the demo here to show you that you can have a part that is cutting through the board. Now, in the embedded part, and that would be in the Allegro miniaturization, you can embed parts. Then when you go into 3D, you're literally going to see visually your embedded parts down in your FR4 material, if that's the material you're using on that design. You would literally see your embedded parts and you would have that height that you could see in real time in the 3D. Understand this is no longer a just a 3D viewer. This is a literally a route engine, 3D route engine. So what I could do is come in here and I could identify that part and I could say move that part, and I could literally move that cap now and have it set up there. That cap has changed. Now I can come back here to my 2D model and notice my cap, of course, disconnection, you got a rat's nest to it, but notice that my cap is now moved up here. So understand that that is more than just a viewer. We've got a true 3D route engine. I can go in there and move parts in 3D, and it happens in 2D. I can move them in 2D and go right into 3D and see that they're interconnected in real time, so there's no delay in seeing that. With that said, let's go ahead and open up a different board, and I'll bring up this board, and let's load yet another design. And I want to go into the 3D flex design here. I got a flex circuit here, and what I want to show you in the 3D is the fact that we have bend lines in here, and we have the radiuses on the flex circuit. You'll see this, they'll take a little while to load, but the bend lines, I will show you the bend lines. You put the angle in which you want that bend to happen, and the degrees in which it's going to bend when you set up your flex circuit. Now, these bend lines I'm showing you is not available in Standard, but if it's already done like this board was, I can bring it into Standard and I can check it and I can do manipulations with it. But again, you can't create that. In order to create those bend lines, you need the Pro version to do that. Once it's done, you can bring it back into this tool, and here it is. And just to show you that you can bend it, I'm in Standard. Just to show you that I can bend it, let's go to the options. I'll take 3 and flip these LCDs right up there on top. And then I'll save some time and just bend everything else, all other bends in there. And what we're really wanting to show you here is the fact that the odd angles of the bends, I can export this out now and take it to my mechanical group for them to look at to make sure that the connectors are lining up after they're all bent where they should be lining up at. And that's part of the bending in there. So let's just, for the sake, unbend everything. Now let's go back into my collision check. So here I want to do some collision checks on this design. And what you're seeing grayed out on the top is actually that metal pan, a shield that's over it. And you're able to see in here the fence for the RF circuit, and then there's a pan on here. Now if I go ahead and hit on that pan I can change whether I want to see through it or not, or have it completely opaque. So I can come over here under Preferences, Setup here, and Symbol Representation, and let me drag this out of your viewing area there. And now I can go ahead and completely make it opaque so that you can just see this solid pan, and that's all you're really going to see. Or I can come back and have it truly transparent where it just disappears. I kind of like it in the 50-degree range there, so if I can get 50, I'm happy. I can see the pan and I can look at all the parts there. There's other features in here that you've got. You can change your colors in there. There's how you're shadowing and your projection angle on there, any messages you want to leave, and any of your interactive. And I'm enabling the 2D, 3D interactive. That's where I said I can move a part in 3D and it shows up in 2D. You need that enabled to be able to do that. And then mask layers, updates, so if I wanted my mask layers. So let's look at some of these problems here. Here's my top pan. Say my top pan and this connector has an issue. Well, yes, it does. I don't have an opening in my pan, so I can't plug that connector in. That is an issue, a very good issue to flag. LEDs down here, D4, D1, and the pan is coming too far out and literally cutting into those, so that pan needs cut back. These are changes that's got to go back to the MCAD group. The other thing I want to point out, this feedback we come from a customer, was working with a customer on there, and they liked what was in 17.2, and they already fed back information to me, which is good. We can send that on to Cadence for enhancements. And one of them, and I thought this was excellent, is there's a push button switch there with no access to it. So they're saying whether you call that a error or whether you call that a warning, at least tell me I got a push button switch underneath that pan that I don't have access to, just like the connector. So I thought that was a very good insight from the customer. We pass that on to Cadence. We're hoping for the next ISR release that they will have flagged switches underneath pans as not necessarily an error, but a warning to say you want to make sure that if you need access to this, you do not have it, the pan's covering it up. So with that said, be sure to send your enhancements in. We're look forward to that. The avenue to do that is through your salesperson. Salesperson will take it to our marketing, and marketing will take it back to Cadence. This particular one, it was so good, I just bypassed everyone, went straight to the developer since I knew the Cadence developer personal, and I thought it was such a good thing. I wanted to get it in on the next ISR release. So I encourage you to give us feedback. We want to support our customers in every which way we can, and you're using it every day, and this is a good example of input that we can use from you to make the tool better. I'll go ahead and close this out. Now I'm going to load one more board. This will be the last board I load, and everything I was showing you there in Professional was also in Standard. So anything I showed you there in 3D with the bending and everything is still in your Standard package. So here we are with Standard. I've loaded this board, and these are the warnings I'm getting. The warnings is basically saying the software is not going to check these. There's rules in there. There's rules in there for everything that you're reading here. I'll go through some of them, but the software is not going to check you for that. You do not have that level of tool. This particular job was done at a Allegro PCB level, not the OrCAD Standard or the OrCAD Pro. So there's things that you will need to check manually. The software is not going to check it for you. That's part of that cost differences between your time versus the cost of the software or renting of the EDA card. In this case, maximum via count. You're going to have to do that yourself. Exposed length, relative propagation delay. I have memory on here. As you can see, it's overflowing outside the board. Relative propagation delay is I got a clock signal, I've got a strobe, I've got data lines, and they're all relative to each other, but they're different type of nets. So I got to make sure I match them according to the type of nets I'm routing. Clock versus strobe versus the data lines. Impedance, total etch length is one of them. Setup layers, constraint region. I got tight pins in this BGA up here. So the constraint region could have different rules than the rest of the design just for those tight pin areas. This type of stuff you have to check manually. It's important that you do that. So let's go ahead and talk about the duplicate type placement. I want to come down here, and we've got a circuit laid out here where here's my RF connector. I got this little circuit in here, and I want to duplicate that. This one down here that's scattered apart, I want it to be exactly the same. When Pro, it would be a two-step issue. I would just say I'm going to define it, and I'd grab all the parts and define it, and I'd give it the origin, and it's done. I just have to group. I don't even have to group. I just put a window around it. Even if the part, like this memory, if I grab that, even if I had that in my group, the software knows not to use it. Again, that's at the Pro level. Since we're here, and I said I can design any board with Standard, this is how I would do that. I want to go in there now, and I want to do just an edit copy. And I'm going to go ahead and make a temp group because that capacitor is a little out of my way. I want to grab these parts here, and then I want to grab that capacitor. And I'm going to use the connector as my origin. The connector's already there, so I don't need to do that. But at this point, I need to say complete. I've got the group, but I want to center in now on this pin. And I'm going to do a right mouse button, and I'm going to say snap to that pin. And what I'm doing is setting my origin. If you look down in the command window, it's saying pick origin, and that's what I'm doing. I'm snapping to that pin. That becomes my origin. I can come down now here, hover over that pin, right mouse button there, and then I can pick pin again. I know for a fact that these parts are perfectly lined up. And if it had etch on it, I could copy the etch and the vias also. So the copy doesn't matter. Then I can come in here now, and I got to go in there and start swapping these out. So at this point here, I want to go up there, and I want to just go ahead and do a place and I'm going to swap components. So it's easy to see this one, U1, U wildcard goes with U21. This wildcard U goes with U23. These are parts that are easy to grab, right, and swap them out. And possibly even the cap, if that cap is literally the same cap, they might be different values, so I want to make sure I have the right cap in there. At this point here, I'd want to turn rat's nest on and start checking to say, okay, wait a minute, all right, this cap here and that cap definitely gets swapped. It gets a little more complicated here, but you can figure it out using the rat's nest, and that's how I would do it, taking the rat's nest and swapping out the parts accordingly for there. So if I'm done with this, I can go ahead. I won't finish all that for the sake of time, but you get the idea there. I'm swapping those out. So let's go ahead and just turn them rat's nests back off on there. So what I want to talk about now is some placement features that you might really like. Let's say, for instance, I'm going to zoom in here. And I have these parts here and they're on the back side. And really what they're asking me to do is maybe take all these parts and put them on the top side and one of them on the back side. But, I've got them on the back side. So how would I do that easily? I don't want to delete them out, place them one by one back in here. So what I do is come out here and I'm going to go ahead and do an export out. And I'm going to export out a pick place. This pick place data is the same pick place as the assembly house uses in their Fuji or whatever pick place machine they have. Load this data in. I'm going to go ahead and create this, and let's just give it a new name. I'm not sure. I'll call it Dupe. I might have already used that out there, but Dupe-place. I'm going to export that out. So I'm exported out a placement file on there, same as the pick place data. Now I want to go in here and I want to look at that. So I'm going to go ahead and bring this in out of my other window there. And there's my Dupe place. I'm going to open that up. Of course, it popped in the other window. Let me bring it over. We can dismiss this back. So I want to go in there now and find, let's say, for instance, I got C7, 8, 9 in here. Let's scroll down here and see where my C7, 8, 9 is. Here they are. So I could come in here and they're mirrored, meaning they're on the backside assembly, and I could take that mirror out of there and just leave the regular space on there. 7, 8, 9. So I've changed 7, 8, and 9 to mirrored parts in there. I could even change the origin if I want. I could change that from 270 to a 90. Anything I can do on here from here over, the origin, whether it's mirrored or if I wanted to change the part. So now I can go ahead and do a file save. I've got that file saved off, and now I can come back in here and I'm going to go ahead and import in my placement file. Let me go ahead and just grab that. Now I'm going to say move, add, but they're already on the board, so that's why I need to move. If I left it there, it wouldn't do anything because they're already on the board, but I'm saying add and move them now. So I can go ahead and import that in. And notice it moved them to the top. I had them mirrored, I've now moved them to the top, and I've got my part now changed. So that's a quick way to change all the parts. You've got a bunch of caps or resistors on the backside. You want to move to the front, you can go ahead and do that. A little editing of the text there, but it'll allow you to do that functionality pretty quickly there. Then the other thing I want to talk to you about is we can have alternate parts. So we've got this old through-hole part. It went into life, can't buy it anymore. We need to change it over to a new surface mount part. So what I want to do is I want to go into my move command, and I'm just going to move this part. Let's see what the find filter says I can move. Spin down. Let's turn everything off. I'm going to grab symbols. I'm going to grab that symbol. It's on my cursor. I do a right mouse button. I say, give me my alternate part for this. And there's my new surface mount part that I have for this device. So there's alternate parts. Some people use this as fanning out the part ahead of time. So when they place the part, they have a fanned out or pin escape part. That can be an alternate also. In this case here, it's from a through hole to a surface mount that has went into life on us here. Now what I want to do is talk about pin escaping. we'll go ahead and pin escape these devices here. But what I want to do first is go in there, and I'm going to activate, or I can do it through here by changing the mode that I'm in, right mouse button, and I'm going to go to Edit Etch. Now I'm going to be into the routing. But what I want to do is go ahead and set up my grid. Under Setup, we should find Grid down here. And what I want to do is set this up so that I have what I call an alternate grid. I have my predominant grid, I want an alternate grid. You won't find this in any manual. This has been with this software since release 1, like I've been with it since release 1. But if you'd come in here and do 5 space 5 till you equal 25, I don't need that last space, and I do it again, there we go, and I'll apply this. Now what happens is I've got this alternate grid, so let's just zoom into this particular part that we'll be pin escaping. And you'll notice, because of the way I set the grid up, the bold grid, if you can see that, I meant to change that. It might be a little easier for you to see. I turn it green so it doesn't hurt my eyes. White is kind of really out there. But what you're seeing is 25 grid. And the little dots that you're seeing are that 5 mil increments. So it's allowing you to really have 2 grids set up at the same time, and you're viewing each one. You know where your 25 mil grid is now, and you know where your 5 mil grid is. It makes it a lot nicer when you're in there. Now you zoom out, you lose those 5 mil grids, so you only see it when you're zoomed in really close, but you can zoom out. So now let's go ahead and pin escape. I really like the pin escapes that we've got in here, so I'm going to come in here under Route, and we're going to go ahead and create a fan out. My first fan out that I really want would be this BGA quadrant style. So let's go up here and just zoom into this part here first. There we are. And what I want to do is change this from the pin via spacing, and in this I really want it centered. So I want to center my pin escapes inside the pin grid array in here. I will include unassigned pins on this that we want. So any unassigned, if there is pins on here that's not at all assigned, it's not going to do anything with that. But with that, now I can come in here and I can go ahead and let's check the find filter. Make sure I got symbols. I click on that, and what you're seeing is a quadrant style. It's pin escaping off to the upper right. This is up to the upper left, the bottom left, and the bottom right. But what it's given me now is a wide opening of copper between these pins. So let me come in here and just do a measurement on that. So I want to turn everything off and just turn my vias on. I'm going to actually get a measurement across there. So I'm measuring from there, and my air gap is 80 mils. So I've got 80 mils of good ground and power coming into the center of my chip. None of them will be starved for any current that's coming through there. It should be adequate to get in there. And that's the whole benefit of this quadrant type escaping of the pins, is opening that up so that you can get some copper down in there to make sure they're not starved for parts. So let's go back here, and we're going to pin escape these parts here. Probably was already in pin escape, but let's go back to it. I'm going to create fan out, and my options now, I'm going to change it, and I'm going to go outward with all these. A lot of the in and out are the same, inward, outward, in and out. East and west would be the same on there, but I'm going to go ahead and just say outward. Now I don't want to go center because it's not center of anything, but I don't want 5. I really want to type 10 in there, so I'm going to put a 10 in there, and that's really putting my via 10 mils from the edge of my pin. I won't want to get any closer. There's some manufacturers that require at least 10 mils. Others will allow you to go 5 in there, but again, it's up to the manufacturer, so you need to know who you're going to manufacture. So I'm going to go ahead and click on that. Notice that it's fanned out. We can zoom in there real close. Notice it's fanned out. But here's the other nice option. Anywhere else on the board that has this type of, I can come up here now. Let's just say done there. I can come up here now and say that I want to copy that fan out. And what I want to do is U6 and any other devices, SOIC20 that's out there, I click on it, and what does it do? It goes ahead and fans out all of them. Now it's copying that, and I got a DRC. You might have saw that pop up there. Didn't get a DRC here, but it got a DRC there. So there's something there I need to investigate. That fan out worked, I'm fanned out, but I got a DRC there. So there's my clock line, and I got an LW butterfly telling me my line width has an issue. Well, that's no big deal. I can come up here and just say slide, the slide command, click on that. And all I got to really do is touch it, and I'm done. Touch it, and it will automatically go to what the Constraint Manager is saying. And again, this is the time to bring up that Constraint Manager. So I'll go ahead and open that up. And let's jump up here to physical. Under here, we've got all my different rules in here, my different vias. I can have different vias for different net names and different groups in there. I want to go also down here to spacing. And under my spacing rules, I can change the different rules that I have here. Let's just go ahead and look at the blind and buried vias to everything. And I want to talk about blind and buried vias versus micro vias just for a second in this tool also. But you have all these rules that you can set up. Now under the electrical rules, the only thing I really have under here is differential pair. But in the Pro version, you've got those min-max propagation delay. You've got the fact that you can set the ohms up for how many ohms you want it and let the software check you. I talked about that earlier. Very powerful in Standard that we can go ahead and set our differential pairs up and route those in there. So with that said, let's go back here to my physical. And I said the different vias, I can set up different vias. What I want to point out here is the fact that if you have micro vias or you have blind and buried vias, put them in the order in which you would use them, starting from the top to the bottom. By doing that, let's just come in here and I'll do a wild card on via. There's my vias. So I can come in here, and if I got blind and buried vias, that's the order I want to put them in. So if I got a micro via that goes from obviously top to next layer down, or top 3 layers, you can't exceed more than 3 layers because it's a laser cut. I can stack these in here, and the software is smart enough to know to use according to what layers I'm on. So if I'm designing with blind and buried vias, it will take those accordingly. Now, what it doesn't do in this tool is give you the spacing for a micro via. So we're here, and you see blind and buried vias, test vias, through vias, but you're not going to see micro vias. It treats micro vias the same as a blind and buried via, but that doesn't mean that you cannot design with a micro via. You can do that. Remember, design any board out there with this. Doesn't mean you want to. So I'm going to go ahead and close this. And let's come in here now, and I'm just going to go Tools, Pad Stack, and let's modify a pad stack. It doesn't matter. I'll grab anything, and let's edit that. I need to pull this over into your window here so you can see. Now, if I'm sitting here and I go to Start, here you can see micro vias. So you can create a micro via and use it. It's just the software is going to treat it as if it's a blind and buried via with the DRC rules that's in the Constraint Manager. That's the only thing you need to know. By definition, how you define a micro via makes it a micro via, not the fact that the software acknowledges it as a micro via or not. You can call it a micro via. That's what we're calling it here. When you click on here, is micro via. Just know that those are normally laser cut. They're less than 8 mils. They don't drill them. Like I said, it's a laser cut. And the fact that you're going to go from layer 1 to layer 2 in most cases, and the most you can do is layer 1 to layer 3, depending on really the pre-preg material that you might have in there, whether or not you can reach 3. And again, your board house will be able to tell you if you can do micro vias down to layer 3 according to your pre-preg materials. Important to talk to those gentlemen and ladies at the board fabricators. They know their stuff, and you can keep out of trouble that way. But understand that you can use micro vias in this tool. It's not a problem whatsoever. All right, Let's go ahead and zoom out. I've pen escaped and I've copied. So I want to go in there and start routing with the differential pair. I go up here and say add connect, and I'm going to go ahead and grab this diff pair. The rules were set up ahead of time, so notice what it does. It goes ahead and grabs those and allows me to come right in here and start routing. It, whether positive or negative, it grabbed it automatically and I can go in there. The problem I have right now is it's not matched. I mean, I need to add some tuning in there, correct? So I'll say done there, and what we're going to do is just go ahead and look at this net. And what are the rules? The rules saying that I have a minimum of 530 mils and I have a maximum of 630 mils. I need to be within those rules, and if I'm not within those rules, I'll get a DRC. So let me switch real quick now to the Pro, just to show you some of the benefits there. So I'm going to go ahead and now I'm going to do a add connect. I'm going to grab this differential pair. Don't matter positive or negative, whichever one I grab, it'll grab the other pair. Now I want you to notice down in the lower right-hand corner, as I'm routing this and I'm putting my line in, notice my phase tolerance is in good shape. I can finish routing that, but you notice the delay is not matching. I'm in phase, that's not a problem, but the delay is not matching. So I can come in here now and say I'm going to tune this and do that delay tuning, because this is a Pro, I have that feature. And now notice as I pull that tuning up, as I get closer to that middle area, now I'm green. As soon as I'm green, I can lock it down and I'm matched my lengths with no issue. Notice, let's see, this one here, we might want to do some tuning here also. Still red there, so let's get some tuning in here. Now I'm green on both of those, that's tuned. But you're still seeing the DRC errors, right? Well, the problem is this got moved and wrapped around there, so I need to go ahead and just slide that back. Notice the DRCs go away, except for this here, that I need some more tuning on this one. But all those DRCs went away because now they're in phase and their delays are matching. I might want to clean this up because I had it center between the two pads, and I can come in there and slide that with no real issues, just lining those up, making it go through there. And notice my 5 mil grid now helps me here. Instead of that 25 mil grid, I have the 2 grids, but it helps me there in my tuning. So that's manual routing. That's routing some differential pairs. Let's now get back out of this tool where we made it a little easier and go back to do some more harder work on there. We'll say okay. It's giving me those warnings that we expect. And again, in order for me to tune this, I would have to go in there and identify it and say what the net is and click on it and then find out what where I'm at, min, max, and the actual, and adjust that accordingly. And I'd have to keep going back and forth to that because I do not have my little pop-up meter telling me that I'm good. You can see where it saved a lot of routing time by doing that. So let's go up here to this BGA. What they've added in this tool now is the router, but the router is limited in this tool to just fan out, and I never used a router for fan out. I want to come in here now and route by nets. Now, in here, I can either route by symbol or grab a 1 net or 2 nets at a time and route that way. I'd use the router for the max I could get out of it, so I'd say symbol, and I'd come in here, and then I would just want to go ahead and click on my symbol. The router starts up. Let's get some details in here, and it's going in there. It checks fan outs, and it's doing its routine, and it runs as many passes as it needs, and it comes in and it does the routing in here. Now, I've got some DRCs I got to go in and clean up, and what I didn't care for is the fact that it was putting some extra vias in here and then not paying attention to the spacing on those. But I can shift and move those. And if you've got Pro, it does it automatically. It's part of the router feature. You can have it do cleanup. The router gets you this far, routed that, made all the connections on there, but you got some DRCs to clean up. So let's talk about what if. A good example of what if is the engineer took all the time to put all these memory chips on here. All right, I've got 8 here. I got another bank of 8, and I got another bank of 8. I can put the memory chips and put them on the back side and put a bank right underneath here, but I'm going to maybe be hard pressed to get the other 8 on here and the termination that I needed for those. Now, that was a lot of work on the schematic part. So if that engineer would have come to me and said, what if I added 2 more full banks of memory? Can you fit them on the card? I could go in here and under placement, and I could place manually, and I'd go to advanced setting and change to my library. And then I can come back here to placement and change this to symbols. Now I have access of my complete library, everything in my library. I can come in here now and I could start placing parts. Let's just say we were adding another BGA in there. I would click on that. Notice it's on my cursor. I could say, you know, if you're swapping that BGA out for this, I've got just enough room for that. Now I can place all these parts and all these memory parts in there ahead of time and say, yes, it'll fit, or no, it's not going to fit. Now when they do the schematic for real and I bring that in, all I have to do is assign those parts, a lot like what I was doing down here when I was assigning these parts out here to the parts here. I don't lose the work I did on the what if, and the engineer didn't waste a lot of time doing that work on the schematic, and then she gives me that net list in, only to find out that I can't get these parts on, we have to do something else. Maybe put DIM connectors in there and add DIM boards if we've got the room. But understand that you can do a what if, and you can plan ahead. It can save a lot of work that way. So let's go ahead and talk about the imports. So we have imports and we have our translators. We can translate PADS database over, PCAD, PADS library, the Altium PCB, and then we have the old OrCAD layout. What we're looking at today is OrCAD PCB. You might have noticed that up here in the name, OrCAD PCB. So what we're doing is translating those OrCAD layouts, the old DOS versions or the old Windows versions of layout over to the PCB. And then now we're supporting Eagle also. So if you've got some designs, because Eagle was passed out free to everyone, and a lot of people jumped on it and then found the limitations on it. And when I say limitations, the examples of max number of parts you could put on it, max number of layers you can have, those type of limitations, and then they come over to our tool. So we do translate those over. Other things that we do is the MCAD, DXF, IDF, IDX. The difference between IDF, that's a baseline, everything comes every time over and over again, the whole kit and caboodle, as they say. IDX just brings the changes. So that's the benefit of IDX, is just bringing the changes that comes over. You can save off your colors and your board parameters, so you can load these in and your colors always match what you expect them to see. You can bring in the tech file. This is the clipboard, so I can make a clip. Notice when I had back here and I had copied these parts and copied them down here, that's really what I was doing, is making a clipboard of those parts. And then you saw me use the placement to go in there and modify that placement file, change those from mirrored parts back to the top, and then replay that in there. So I'm looking at time, and let's go ahead and jump into the Constraint Manager just for a second here. And let's get down to the manufacturing and expand this so you can see. This is what we're doing. Most of you might not understand what Valor is. Valor is a check that the board house does. They're doing Valor checks, basically to see if you're following their rules. What we want to do is say, why do that as a post-process? Definitely why do that after you've sent it to the board house and you're waiting to hear back from them. When you really think they're building your board, they're doing checks on it just to put it on hold and send it back to you to tell you there's problems. And trust me, if they overbook, they're going to find some reason to put your job on hold. So we want to bring those checks right up front, and that's what we're doing here. True to the design, it's going to come out already set up. You're going to find these manufacturers out there, and you're going to use their rules. You're going to set their rules up. So you'll apply those rules. You'll know for a fact that these manufacturers can build your product if you fit within their rules. TTM, for example, 5 mil to the edge, traces to the edge of a board. I know TTM I can actually do edge plating. I have a board where they brought copper right up to the very edge and then plated that edge of that board to seal that board off. Military, expensive, but they can do it. Assembly. So if you want to go into the assembly house, they have rules. You can set all these up for all the rules for your assembly houses. I guess shame on me for not putting Jable circuits there. I was a CAD manager up there for a number of years, and I never added Jable circuits as one of the assembly houses. And then we have the design for test, and you've got those vendors out there that build your test fixtures and stuff like that, and you can, you know, right up front design it. You don't have any issues. You send your data off, you know the data is good. You've done these checks right up front. These checks are limited in standard, but they're here, the minimums here. They expand as you go up into the Pro and into the Allegro version of that. One other feature I wanted to talk about was the fact that shapes was brought up. So let's go ahead and talk about shapes. So I want to real quick get a ground in here. So what I'll do under shapes is I can come in here and say I want to do a Z copy, and I'm dealing with my ground, so I want to do L3 ground on here, and there's my etch. I want to create a dynamic shape. There's two different shapes we have, dynamic and static. Dynamic is fluid, changeable. You can modify it. It heals itself. You don't have to open up and deal with it. It takes care of, software does everything for you. So think of the days where you used to call it open it up and re-pouring it. The software is doing all that for you. That's the dynamic shape that we have here. I'm going to Z copy it. So what I want to do is go ahead and I want to change this and I want to contract it back by 15 mils. Because I know what board houses I'm going to go to that I need 15 mils on that. So I'm in the command Z copy. You can see that down in the lower left corner down here. Keep an eye on that. If the software is not acting like you think it should, make sure you're not idle, that you're really in a command. So I'm going to go ahead and click on, let's see what the find filter says, shapes or outlines, that's fine. So I can click on this outline here, and it's literally created that shape for me. But it's just a shape. It's not intelligent yet. I need to make it intelligent. So there's a number of ways to do that. I can identify the shape and grab it. And I can come over here and I can find it and I can say ground here. Or I can come over here and hover over this pin, click on this pin and do a right mouse button and say assign net, and it'll assign a net that's on that pin. So there's two different ways to do it. I can do it through ground, or I can do it through clicking on this pin. And there's my ground. I can Z copy then again for the power, and I can actually pull it back further back from the ground, making the board itself like a capacitor, having the power and ground, two different shapes. I can pull that back. And I've done that on some boards. Basically, think about it. You're building a capacitor with your power and ground planes in there, pulling it back a little bit more and build this overall capacitor across the entire board. Other things that you can do with shapes. So we're in shapes here, and we'll allow you to manually isolate, put a cavity in there. We allow you to merge shapes. So you might have two shapes that are ground for whatever reason. You can merge those together in there. The nice thing about it is in these shapes, we allow you, let's say for rectangle, you can define it and just place this rectangle 100 by 100. There's my shape I'm placing. Also, I can come up here now with my shape and say circular, and there's my circular, and I could place that. So you're predefining that and just placing it out there, whatever shape you want. Of course, you can always open that up and then start modifying that shape. I mean, there I would want to go ahead and just stretch it. Very easy. Change the way we do shapes, making it easy to modify them. Let's go ahead and just start routing, for instance, because I talked about that. So let's go to this, and let's say I was going to route out of here. So I'm coming in and I'm just going to route down and into that part. Notice that this is that part I was talking about where it's healing itself. It opens it up. It lets me route in there. I don't do any of the work. It's following the DRC rules. It's giving me that gap because those are the rules I put in the Constraint Manager, which I call the brains of the operation. It's doing all that for me. No matter how I route it, it opens up and allows me to go in there. That's dynamic shape. If this was static shape, I'd be getting a DRC. Where do I use static shape? I'm doing an antenna RF circuit. I don't want that shape to move. I need it to hold its position. There's where I'd use a static shape when I'm doing copper instead of a dynamic shape. So I know I've run over. I love teaching, and I hope this has been very beneficial. So I'm going to pass it back to you, Brianna.
Thank you, Orlin. It's okay. And at this time, I would like to encourage you all to enter your questions, if you have any, into the questions pane. We are running over time, but I will ask one question here, Orlin. What format is required to import StackUp from the board house?
I prefer to use the IPC Standard because that has IPC Standard has developed quite a following now. The ODB++ used to be the golden child, so to speak, but now with the IPC Standard, that really is the best way to get those in there. Again, I will go ahead and pop that up. So to import in the IPC 2581, check with your board house whether they have the technology file, HTML file, but the IPC 2581 is the best way to get that information in there, most accurate.
All right, thank you. So at this time, if you weren't able to address your questions, we will be following up with you. With that being said, I would like to thank all of you for joining us today, and thank you, Orlin.
You're welcome.